Let's take a look at Instana's Unbounded Analytics feature. Unbounded Analytics allows me to slice and dice all the unsampled, high cardinality data that Instana captures. Analytics is accessible by clicking on the magnifying glass icon in the selector. You can also jump in context analytics from other areas like websites, applications, platforms, etc. For my purposes, I am going to jump directly into it. As you can see, I'm able to choose between application data in the form of calls and traces, website data in the form of page loads, resource retrievals, etc., mobile application data, and profiling data. I'm going to stick with application data today. I have the ability to filter and group the data. I can filter using the filter toolbar, where all the most common filters are available. And then I have the All Filters button that allows me to choose from the full list of tags. These tags include call level tags, for example, things like HTTP status, as well as infrastructure tags, host names, zones, things of that nature. I can also group the data. You'll see that there's a group by button here, and I have the same list of tags that you just saw in the All Filters button available for grouping. Now, for my purposes today, I'm going to focus in on a particular application perspective. I am part of the billing team, so I'm going to choose the billing team application perspective. Great. Now, the default grouping, as you can see, is the endpoint name. I'm going to change that to service name. I prefer looking at the data from a service name perspective. As you might remember, services are comprised of endpoints, so this will roll all the endpoints up into their services. Perfect. So I can see over the time period that we had calls to some backend services like Redis and MySQL, as well as some external services like PayPal. So already very helpful information. Now let's talk about the table itself. I can see the count, the earliest timestamp, the mean latency, and the erroneous call rate. Now, I don't know about you folks, but I'm not a big fan of mean metrics because averages can hide problems. So I'm going to go ahead and select a different metric for the latency. I'm going to select the 95th percentile, and I'm going to remove the mean latency. Awesome. So now I've got the 95th percentile here. I can, of course, sort on it. I can see that the numbers look pretty good. The payment service, obviously an important service for us, is the slowest, but it is still under a second from a 95th percentile perspective, so that's pretty encouraging. Another thing I might want to do, though, is to see how these services have been performing over time, and I can do that by clicking here on the Show Graph button. As you'll see, I have the same metrics that are displayed in the table available for me to graph. So right now I'm graphing the count. You can see since I added the 95th percentile, it's also available for me to chart. But what you probably already noticed is that something strange happened here where everything was humming along just fine until here when the call count dropped precipitously and then it went back up. If we take a look at the latency, not surprisingly, we see that the latency spiked up at the same time the count dropped. And I bet if we look at the erroneous call rate, sure enough, we see that there were errors at that time. So again, everything was humming along just fine, no errors until this time period when all of a sudden we saw errors occur. Now, it might be nice just to focus in on this time period, which we can do by simply swiping across with our mouse, zooming into the time range. Now we're looking at just that time range around which the errors occurred. Now, since I am focused on errors, it's probably good for me to just filter for them, so I can modify my filter to include erroneous calls. At this point, I can probably hide the graph to save me some screen space. And I can see that there were 3 services that threw errors during this time period: the catalog demo service, the discount service, and look at that, we've got a MySQL database service that threw errors. Another thing interesting to note here about this database service is that it did peg at pretty much exactly 5 seconds, so that would tend to indicate something like a timeout or something like that. So I'm going to dig into that service. I'm going to click on the MySQL service. I can see that there were a bunch of errors at the connect call level, and I can then drill into one of them to drill into the trace that made that call, and I can see right away that the connect returned an error here where the connection was not available. If I take a look at the full trace context here, I can see that the connect returned that error. The connect was called by the discount service, so the discount service errored. The discount service is called by the catalog demo service, so it then errored. So we've got 3 services that errored here in this trace: catalog, demo, discount, and MySQL, and it's all because of the connection pool problem in the MySQL database. That meshes up perfectly with what we see here with these 3 services, but again, the root cause would be the connection pool problem in the MySQL database. So this is really just one example of using Unbounded analytics to slice and dice through the unsampled tracing data. I encourage you to experiment with the filters and groups. I guarantee you'll be amazed at what you'll find.